Assalamu alaikum wa rahmatullahi wa barakatuh, and good morning, everyone. Can you hear my voice? Is it clear?
Yes, madam.
Alhamdulillah. I want to ask, we still have one more group didn't present. Is that true? Any group didn't present? Just let me double check that one. Brother Ahmed. Okay, we can check it later, inshallah. So if any group didn't present yet for project one, please write in the chat box. At the end of the class, inshallah, we'll give you time, inshallah, to present. Okay. Today we can continue, inshallah, the VLANs. Give me a second. I'm trying to find the slides. Okay, so just share the screen. Just a second, sorry. I want to see the chatting box all the time, so if you're right, I can read it directly. Okay, so VLANs, we finished, I believe, the whole chapter. I just want to double check. VLANs all there. The trunking also done. Dynamic trunk protocol. We did that one also. And I gave you one assignment to do. 361. Okay. Before we go to interVLANs, do you need one extra backtracer exercise before we move to the next topic, or you think it's okay now? This next topic really depend on this one. Proceed. Okay. Or one more example. We do it together. No comment. It's a good thing or bad thing. Okay, let's go to interVLANs, and maybe after we start, if we need, we can make a small network and try this one here. Now, as we said, for VLANs, we are trying to segment the network. But in reality, when you try to communicate with the other people, you should not be isolated. We said that HR people, we want to put them alone, finance alone, okay, in one subnet, one VLAN. However, HR and finance, they should be able to talk. Last time when we isolated them, that means it's only for management purpose. We isolate them. So the control messages, the broadcast messages, they will not be sharing those. But when it comes to real data, they want to talk. HR staff should be able to contact students. We cannot simply isolate them. So we have to do what we call inter-VLAN routing. Inter-VLAN meaning that the different VLANs should be able to talk to each other. And to do so, we need a router. Because remember when we did computer networking subjects, we said the router is the gateway to go to another subnet. Same thing for VLAN, although we are in the same location, same switch, but virtually we are separated. So you need a router to do that. Now for inter-VLAN routing, VLANs use segments, as we said, to segment the network, but they need to contact each other, should be able to communicate with each other. Now, sorry, to do that, there are three ways. One of them we call legacy inter-VLAN routing. Legacy means that it doesn't exist anymore. It was an idea, we used it. From there, we learned how to do the other two methods. So now we can talk about it to understand how this inter-VLAN is working. Legacy inter-VLAN routing, It's not scalable at all. You see why, okay? But because of it, we learned how to do router on a stick. Router on a stick, this is what we use usually in small and medium-sized network. And when you have something like a scalable network, like IIUM campus, it's very large. Router on a stick is not the best solution because it's a little bit slow compared to the other one, which is layer 3 switch using virtual interfaces, okay? This one, layer 3 switch, we don't have it in Cisco Lab. It's not a normal switch. It is more expensive, but we have it in Cisco Lab 2. So I'm not sure if we will have a chance to go to Cisco Lab 2 because the aircon is not working now. We will see. Maybe we have a chance to take one of the switch and use it in Cisco Lab if we get a chance to go there. So layer 3 switch using switch virtual interface is the best one for a large or medium to large organization. Now, what's the idea of this one? Legacy inter-VLAN routing. Simply here, we would deal with the router as the gateway for the two different subnets. And we know the subnet are VLANs, right? Two different subnets. We would deal with the router like that. However, because the subnets, both of them, or the VLANs, both of them are connected to the same switch. So we have one line going to the router on one interface and another line or another cable from the router to the switch again to represent the other VLAN. So from router to switch, we have two lines. The problem with this one is the router, you remember when we opened the packet tracer, we have very limited number of interfaces for the router. So if you have two, it means that you will not have, you cannot connect too many devices. Let me show you that one. Let's open packet tracer. Packet tracer. Okay. Sorry, packet tracer always take very long time to open. Okay, this is packet tracer. If I put one router here and check the number of interfaces, you can see here I have 3 gigabit Ethernet. If I use 2 of them to connect 2 VLANs, that's it, right? We cannot use for another VLAN. If we have 3 VLANs, we will use a 3 gigabit Ethernet. So it's very limited. Now for networks like IIUM or even KICT alone, that's not reasonable at all. You have very limited number of ports. You use them to connect 2 devices only. Not okay. So that's the idea why legacy is not used anymore. However, it's very, very useful in terms of how good it gave us the idea how to do it. And then we move to the other different VLANs. So if I want to do this one, let's do this network actually. You can open your packet tracer and let's try to talk about the inter-VLAN. Can you please open your packet tracer? And we can do it together. Okay, I will assume that the packet tracer is already open. So what you need to do, if you remember for VLAN, we put a switch and the switch will be configured for different VLANs. And I need, let's say, 4 different computers. So we will have VLAN 10, VLAN 20, VLAN 30. Forget about the router. Let's remove the router, or I will not even connect it, so it's fine. I'll connect the devices in here. So this one, fast Ethernet, go to This is 0. Let's do it 1, 2, 3, 4. So we will not get confused. We use straight through again, pass Ethernet from the computer to F02. This one, pass Ethernet to F03, and fast Ethernet to F04. Okay. Now for VLANs, I will put this one, I'll call it PC1, VLAN 10. Okay. This one, I'll call it PC2, VLAN 20. I don't write VLAN because it will be too many words in the screen. It will be annoying. So I just write V30, VLAN 30. And this one here, VLAN 40. Okay. Now, can you tell me in the chat box, what is the next step to do the VLANs? Can you tell me what will be the next step? Because usually when we have a break for a project, students forget how to do the configuration. Anyone? After the physical connection is done, what should be the next step?
Name VLAN. Configure at the switch.
Okay, but before that, we have to do the subnetting, right? Subnetting first, then we configure the VLANs. So let's do the subnetting since, sorry, this one must be VLAN 30. I don't know what it is. VLAN 10, sorry, VLAN 10 and VLAN 20. My mistake, sorry. 20, and this is PC4. Okay, so now we know which devices should be able to contact which device. If you try to ping now, it will not work because there's no IP address. So let's do it like that. PC1, VLAN 10, we'll give all VLAN 10 the IP address 192.168.10.something. So here I'll give it .2. Same subnet mask. Then I'll go this one, give it the gateway. Should I give the gateway or no gateway?
No.
No gateway. Since there's no router, so no gateway. Okay. So now I will go here, PC 3, which is also belong to VLAN 10. I will give it 192.168.10.3. Okay. So this is, they can ping each other. We can try. Ping 192.168.10.3 should be fine. Okay, so this is the first thing. The two devices can ping. I will go to VLAN 20 now. PC2 VLAN 20. Try to configure the IP address 192.168.20.2. Same subnet mask. And PC4, I will give it 192.168.20.3. Same subnet mask. Now, if I try to ping PC2 to PC4, it should be working, right? Because they have the same subnet. Ping 192.168.20.3. It's working. Now, if I want to ping PC1 from PC2 to PC1, so it will be .10.2, I will not be able to get the reply. Why? Because the IP address belongs to a different subnet. If it's belonging to this different subnet, that means we need a router to let us know how to direct that packet or frame. So without the router, they will not be able to talk. And put in mind, we didn't even put any configuration for the switch yet. It's only the subnetting disallowing different VLANs to talk. Now we go to the switch. Inside the switch, command line interface, type enable, config terminal. And then when we are there, what should we do first? Okay, what should be first? This is set IP. This is a previous question. Okay, we should initiate the VLANs, right? Just type VLAN 10. Call it whatever you want. Always use the very creative name, VLAN 10. No effort at all. Okay, 20. Then name VLAN 20. Now, should I do the native VLAN as well? Do I need native VLAN? What do you think? Yes, no? Okay, you forgot what is native VLAN, or there's a big delay. I don't know. Okay, so the idea for native VLAN, if we have two switches to talk to each other, which will make the trunk. Since we don't have a trunk, simply we don't need it. Just use the basic one, okay? I will exit this one. Now, when I'm out, I have to set the VLAN. How to set the VLAN? I will go to the interfaces, interface F01. In F01, switch port, mode access, switch port, access, VLAN 10. As simple as that. Now we know that F01, which is connected to this computer here, PC1, belongs to VLAN 10. Now I would do the same for F03, which is connected to PC3, F03, exactly the same commands. This is done. You see the light here? It is orange color. Orange color meaning that the switch have some changes. Now it needs to communicate with the other side of the link to reset or to establish a new connection. Now let's do the next one, F02. F02 is the same except for switch mode access, then switch access VLAN 20 instead of 10. F04, same thing. Okay, done. So now the VLANs are set. If I want to double check, what should I, how can I check if it's working or not? How to verify our configuration working or not? Okay, yes, do show VLAN brief. When I look here now, what I will see that F01, F03 are inside VLAN 10, and this one in VLAN 20. It means it's fine. What about ping? Can we do ping to verify the VLANs? I've got computer one, try to ping. Will that work? Is that enough? Busy doing it or delay again? Okay, so we try to ping, nothing will change. It's the same thing. VLAN 10 can ping only VLAN 10. and VLAN 20 cannot be pinged from VLAN 10. So let's try that. So what changed? Actually nothing, except that now when they have the broadcasting, we will not send to all the switch ports, only for the same VLAN. So for management, it's okay, but we need the devices to talk to each other at the end. It's not okay to say the devices are completely isolated. To do that, as I said, switch cannot do that. The router is the only one to do that. So now I need to connect the router to the switch. So I'll go to the switch G01 here. I will connect it to G000. Fine. Okay, we will need to know this one later. Okay, at the router now, also I need to connect the legacy type or the legacy method. I need to connect another link from the router to the switch. Let's see why that will be done. At the router G000, it became the gateway for VLAN 10. G001 is the gateway for VLAN 20. So enable this one, configure terminal. Okay, so in here, I'll go to interface G000. And tell this interface, you are having the IP address from VLAN 10, which is 192.168.10.1, 255.255.255.0. No shutdown. Okay, go to interface G001 and I give it the IP address from VLAN 20 and make sure you do the right one. If you switch the IP addresses, it will not work because the link is configured like that. Okay, it will not work. So say no shutdown. Okay, now the router became the default gateway for the VLANs. Second step to do is to go to the computer, tell it about its own default gateway. We didn't put any default gateway. Now we have to tell it 192.168.10.1. We do that at each of them. 192.168.20.1. This one here will be 192.168.10.1. One 192.168.20.1. Done. Okay. Are you done? 100%? 70%? Should I wait a little bit? Am I going very fast? Can you write in the chat box? 100%, 100%. Okay. For those who finished 100%, can you ping PC1 to PC2? PC1 to PC2, is it working? Do you get any reply?
No.
No. What do you think is missing here? VLAN 10 can talk to VLAN 10. VLAN 20 talk to VLAN 20. If they want to talk to each other, they need the router. So we put the router, put the default gateway. What is missing? Can anyone guess? We configured the switch, right? We put the VLANs at the switch. We said F01, F03 are VLAN 10. F02 and F04 are VLAN 20. But we didn't tell G01, G02 belong to which VLAN, right? Those which connecting to the router, we didn't tell them you belong to which VLAN. So by default, the switch will look at this one, okay, F01, let me draw it. A message will come from F01. The switch will look at it, okay, you belong to VLAN 10, you have a gateway, but when I look at my ports, I just see this one. This is VLAN 10. There is no other VLAN 10. I cannot send the message. Since it is VLAN 10, it will not be sent except to VLAN 10. Okay, so simply it will not send it anywhere. Stop it. So if we wanted to go from here, from PC1 to PC, to the router, okay, go in here and then do the U-turn. Okay, to do the U-turn here and come back, go to V20. We have to tell G01, this one, G01 and G02, that you belong to VLAN 10, V10, and you belong to VLAN 20. Okay, so if we don't do that, simply the switch will not know how to deal with the frame it's receiving. So let's do that one. Let's fix this problem. To fix it is very simple. I go to the switch. At the switch, I go to interface G01. And in G01, I'll tell it the same story. As switch mode access, switch access VLAN 10. In G02, I will tell it switch mode access, switch access VLAN 20. So now when any message go from any of the VLANs to trying to go to the other one, okay, you look at the link here, the light turned to orange color. So if you try to send now, it will not reply directly because they are still configuring. If I try to send from here, it will see, oh, to the gateway. So I will send the message here and here. This one will reach here. Okay. It will know that now I can do a U-turn, come back, and send to VLAN 20. So let's try to ping now and see if it's working or not. Okay. So VLAN 10 trying to ping VLAN 20. You remember I said there's a U-turn at the router. So we expect the first one, maybe it would take time and maybe the first one we will not receive it. Second one also should be okay if it's not received. But later, now you can see VLAN 10 is talking to VLAN 20. Let's try same thing, VLAN 20 to VLAN 20 to VLAN 10. You can see it's working. Okay, are you done? 10%, 100%? Anyone? Can you write in the chat box?
Yes.
Okay, 100%, alhamdulillah. So what I will do now, I will go to iTalim. From iTalim, I will try to oh, I forgot that I want to give you project 2 today. Let me just double check if I uploaded the file or not. I need to do that. Let's finish this one and then I give you project 2. Because it would take time, so better to do it, give it to you now and see what will happen later. Okay, so in iTalim, I will put a link for you to enter VLAN. Okay, sorry, I didn't show a pic. So there is a video. Enter VLAN, this one, submission, enter VLAN. I'll say two VLANs. Okay, this is to be submitted before the end of this class. Okay, I will not accept any late submission. before the end of this class. So today is 18th. I don't know how we are in November. How fast is that? End of the class will be at 10:30. Okay, 10:30, and then you can submit it. Okay, let's move on. Okay, let me hide the unnecessary exercises there. Show them when we need them. Okay, but you can see that after we finish this chapter, inshallah, you will have a Cisco Net Academy exam module 1 to 4. So whenever we finish it, we can go for it. Okay, now I want to improve my network. How I want to improve it? Simply, by time I got a new computers, and I decided to add VLAN 30. So this is VLAN 10, 20, and now I will add another 2 computers to be VLAN 30. This is PC. Okay, this is 3, 4, that will be 5 and 6. 2 computers. I want to connect them. So F05 and F06. And let's call them something. It will be PC5 VLAN 30. So I decided to add one more VLAN to the network. What should we do first? Can you tell me? Or let me do something. I will not do this one. I'll give you a break. Okay, not break, a break for me. And let's have 10 minutes. Try to let V30 talk to everyone. Okay? 10 minutes. I'll give you a break. Do all the necessary changes in order to let V30 talk to the rest of the devices. Fair? Okay. After the 10 minutes, whoever will be able to show me the screen that it is working, I will give 0.5 bonus mark on the carry mark. 0.5 bonus mark if you can let V30 talk to everyone. So I will stop sharing here. I'll give you 10 minutes. So until 9:22, whoever can share the screen and show me that it is working, I'll give 0.5 bonus mark. See you after 10 minutes.
Madam, I have question.
Yes, brother.
Since we will create the new VLAN 30, is it we need to add another port to become a gateway for VLAN 30?
Yes, you need to add another port if necessary.
And
So you connect
since the
switch to
router,
the router.
in the interface for the router is already full, so we need to add another port lah.
Yes, you need to add another port. But one thing, at the moment you switch off the router, you will lose everything. So either you reconfigure all the interfaces again with the IP address, or make sure you save, go to the privilege mode, type copy running to startup. Let me show this one. Okay.
How?
Be fair. Okay. So to make sure that you will not lose the configuration you did, because to add another port here, you have to switch off the device. The moment you switch off the device, you lose everything, right? So what you need to do in here, enable, in the privilege mode, type copy running configuration. So run to start, just like that. Your get destination file name is startup config. Yes. Now your changes will not be deleted after you switch off. So add the switch off the router, add the port, switch on again, and continue. Okay. That hint, I shouldn't give it to you, but it's fine. Okay, so let's see who can do it. Okay, so anyone done? Raise your hand if you are done. Can you ping the devices? Okay. So let me ask, do you need more time or you give up and you want me to do it? We do it together. More time or we do it together? If more
I
time,
have a problem, madam.
yes. With what?
After I insert a new port
Mm-hmm.
at the router, but I cannot do what is that? I can give the IP address for the new port.
Oh,
It
okay.
when
That's
I
port.
put the question mark, it show no IP address.
Okay, the port you put is called switch ports, right? It's not a router port.
Yeah.
Okay, let me show you this one. Let me share and show this one. Because in router, you can add some ports, but they are, if I go to physical and try to check the ports. Okay, see this one called switching ports. What's the meaning of switching port? It means it's a port doing switching, what? Functions only. IP address is not in the switch, so these ports will not know the switching. So if you check, if we have any more, actually you will find there's no more. That option is not there. So how to fix it in that case? And this is one of the drawback. Actually, I wanted to see if anyone will figure it out or not. This is the one of the things. In that case, you have to remove the router, bring another router, which is having enough ports. So if you go to the other router, let's see this one, how many ports it's having. Even if I stop here, you can see this one is having 2, so it's not enough. Let's take this one, 1941. It's having 2. 2901. I think this one is having 3 already. Nope, 2. 2911. There is one of them having 3. Let's see which one. See, this one is having 3. So this one, you don't have to add another port. It's already there. So the problem with the legacy VLANs, that if you need 3 VLAN to add one more VLAN, you need to change the whole router to get the right VLANs. Okay, I will give you 2 minutes. If anyone can fix it. The one which will have 3 VLAN is 2911. This one, sorry, yeah, just 2911. Try to exchange it with this router. Give you 2 minutes. If you can do it, you can get the 0.5 bonus mark. Otherwise, I will get it. I will do it for you, and no one will get it except me. So 2 minutes until 9:27, and then we see if anyone can do it. Okay, anyone done? Raise your hand if you are done. Okay, I'll give another 1 minute. Then we see if anyone done will get 0.5 bonus mark. Okay, anyone? Raise your hand if you are done. Still not working? Okay, that's it. No more 0.5 bonus mark. I will get it for myself. Now let me try to do it, and let's do it together. As I said, because of the limitation of the router itself, we will not be able to use the same router in order to fix the problem of adding another VLAN. I need to remove this router and bring a new one, which can have enough ports, 3 ports for 3 VLANs. So for here, what I would do, I will connect, okay, the switch. You can see, oh, that's one. Where's that one? Not, I chose the wrong one, sorry. Sorry, I gave the wrong information. Which one is it's the last one here. This one having the 3, yeah, this one having 3 ports. So let's connect. I will connect here. This is another thing, interesting thing. See, we have only 2 gigabit Ethernet at the switch. So what will happen now? I will connect gigabit Ethernet to gigabit Ethernet for VLAN 2, G02 to G01 here. And for the other VLAN, you see no more G0, 2, 3, or whatever. So I can use fast Ethernet. Fast Ethernet, the name is fast, but actually it is much slower than the gigabit Ethernet. The speed will be following the fast Ethernet. Okay, so now we have 3 of them. Now we really need to remember the name. Okay, G0. Okay, I will try to remember the name. Okay, at the switch, we did the configuration. Let's check the configuration. Enable, then show VLAN brief to see if G0 is anywhere. So you can see that we already have G01 and 2 here. So now we just have to deal with the other one, which I completely forgot which one is the other one. That one was what? F022. F022. Okay. So this one, I have to add it to VLAN 30. But to add it to VLAN 30, there are something we have to remember. VLAN 30 is not here. So I have to create VLAN 30 first. So let's do config terminal. VLAN 30. Name VLAN 30. Okay. Exit this mode. Go to interface F022. I don't know which number you used. You can use the same number. Switch port, mode, access, switch port, access, VLAN 30. This is done here. Now I will go to the, here it is, which one? G012, 012, both of them, all of them should be reconfigured. It's a new router. So everything should be reconfigured again. Enable config terminal. And when I do config terminal now, I have to go to interface G01 or G00, what's the name? G00. G00 is the one connected to VLAN 10. So I have to give it the IP address from VLAN 10. IP address 192.168.10.1.255.255.255.0. No shutdown. And next, interface G01. IP address is the same, but we change this one to 220 instead of 10. And no shutdown. Then I'll go to G02. G02. IP address is 30.1. Shutdown. So at the router, we are done. My question now, can we ping now or we cannot? Let's try VLAN 10. I tried to ping someone from VLAN 10 as well. It's working. Someone from VLAN 20 would take time because it will go to the router, do the U-turn and come back. So it's expected first one, maybe it's not working, fine. Second one, not working, still fine. Third one, if it's not working, we have to worry a little bit. Fourth one, nothing. So something wrong. There's something wrong. We did something wrong. And this is the issue with VLAN. It could be anywhere. VLAN 20. So what I have to do first, if it's not working, I'll check the gateway at all of them. It's here. This one is having gateway or not. It's having gateway here. Because if the gateway is not there, fine. So now what I would do at the computer here, when I tried to ping VLAN 10, it worked, right? But 20 didn't work. Let's try to ping the gateway for VLAN 20. See if that will work or not. I'll go to 20.1. If I can get reply from there, it means that it's fine to go from my computer to the router, do the U-turn and stop there. If it's not working here, it means, you'll see this one, how it will be. So what I pinged here is simply, okay. What I did, I connect here. I'm trying to see if I can reach here and do the U-turn, okay? Now, for me personally, I cannot. It means that I missed something somewhere. Maybe some of you already got it. The chat box, someone could do it. So it is just a matter of something wrong I did here. Could be the interface configured wrong, but the problem is very hard to see what's happening at the interfaces. Okay, so just for me, you don't have to do that. I need to double check that the G0, 1, 2, and 3 are configured like the right interface, because okay, G01 here, go to G00, G02, go to G01, and then we have F022, go to G02. So just make sure that the physical connectivity is right. This is first thing I did. Now I need to check here. That's exit. I want to show the IP interface brief. I want to check the IP addresses, no typos. So you can see this is the IP addresses, should be okay, and all of them are up. Let's try to ping Here, one point thing, or one more thing I need to check. Exit. Do show VLAN brief. I just want to make sure that I have the correct one in the right place. Okay, so let's see. Now maybe it will work, who knows? Oh, okay. So the brother said you just need to keep try to ping until it will work. To take time, because as we said, instead of sending from the switch directly to the device, it took some time to go up, you turn and come back. So maybe that's the issue. I have a feeling I forgot something. But we need to know what is that thing I forgot. No, it's something is not working. And for me, actually, I know that there's another issue. I didn't say it. I wanted to ask you why it's not working, and you tell me. I didn't put the IP address here. So let's put this one, 192.168.30.2, same one. And then we have 192.168.30.1. And here also we need to put the IP address. 192.168.30.3, 192.168.30.1. Okay, not only that, at the switch also, I have to assign F05 and F06 to VLAN 30. I didn't do that, if you remember. So I do this one, I have to go to, did I actually? Yeah, see VLAN 30 is only having F022. So now I have to go to interface F05, switch port, mode access, switch port, access VLAN 30. Then F06 should have the same configuration, mode access and VLAN 30. This is, let's double check, do show VLAN brief. You can see here that is there. Okay, let's try to ping here the two devices. Ping 192.168.30.3. We look at the light. First one was orange. After it turned to green, we got the reply. Now let's try .20.3. It's working. .10.3. It's working. So just a matter of time. And for VLAN 30, make sure that you configure everything else. It's not only you give the IP address, you forget the router, or you forget the switch. All of them should be configured. So this is done. Let's go back to VLAN 10, see why it doesn't want to talk to VLAN 20. 20.3. Working now. So that's just a matter of time. To do the U-turn, needed time. Okay, VLAN 20 talking to each other, to everyone, should be working since it talks to some of them. 20.3 is fine. 10.3 is fine, should be fine. And then 30.3. So again, just make sure that this is how to check. You have to ping all the devices to each other. If you don't know how to to ping. This is what happened in the final exam, final practical exam. Students do the network, but they don't know how to check, is it working or not? Okay, so this one also, I want you to submit it to Italim, save it, and submit it. I will give you until, submit it at the end of this class, but I will keep it open until, when should I stop it? Let's say midnight, okay, until midnight. So this one we call 3 VLANs. Now I want to ask, can we do 4 VLANs? Can I add VLAN 40? Can I add VLAN 40 to this network?
Need another router that have 4 port.
You will not find that router in the market. Actually, what you will need in that case, you need to buy another router, put it here, and connect it to the network. So the U-turn will not come here, it will come to the other router. So you see how much it's not efficient at all. That's why we decided not to use it. Now, if you want this one, to add VLAN 40, you have to buy a new hardware. VLAN 30, you need a specific router. That's why we call it legacy. It's not used. The idea is nice, but we found a better way, which is router on stick. So I'll stop here. I want to ask, we still have one more group that didn't present last time. Is that true?
Yes.
Yes. Okay, can you present now?
Wait, medium.
Oh, sorry, due date is wrong. Okay, I will fix it. Brother, you can share your screen. Okay, let me stop sharing. And you can start presenting. However, you have only 10 minutes to finish, maybe 11 minutes, okay? Because I have a class after this.
Can you share the screen, madam?
Yes, we can.
Okay. Okay. Assalamualaikum warahmatullah. My name is Muhammad Iqbal, 2317327, and our group will present about multi-access edge computing, MEC, and security is a review of proposed MEC security frameworks. So now we have 5G, which is the latest generation of mobile networks. When compared to previous networks, such as 4G, it is much faster, provides very low delay, latency, and can support any devices at the same time. Therefore, this improvisation from previous networks to 5G and beyond will increase amount of devices connected to the internet, meaning more growth of IoT devices. These IoT devices is data heavy and needs real-time responses, which means you cannot afford delays. Therefore, to handle these devices, network must improve, the standard must improve. Therefore, the devices requires more demands and the network must be more dynamic in adapting to various situations. However, traditional cloud systems cannot fulfill the computing demands of these devices, such as it cannot provide real-time responsiveness, quality of service, etc. because the data need to be sent to faraway servers, meaning more congestion and delays. However, MEC can meet the computing demands required. It provides low latency, high bandwidth, and real-time services in 5G and beyond networks. Therefore, MEC is crucial to handle current technologies. So how do they meet these demands? It meets the demands by it brings the computation and storage, which means its edge servers and base stations closer to end users instead of sending data to the distant cloud server. Therefore, MEC can support low latency and data intensive apps like IoT devices, autonomous vehicles, and smart cities. However, MEC has its security challenges, such as low-cost edge devices. These devices have limited CPU, memory, and power compared to big cloud data centers, meaning it will cause network congestion, affect the latency, and inefficient resource use. Next, the data is spread across many edge servers, meaning there are more entry points for attackers. Next, local servers may have weaker protection for sensitive information compared to big cloud data centers. Lastly, it's regarding the data privacy, where communication over public networks can expose sensitive data to interception, and also thus attacks can overwhelm or resource-constrained edge servers. Therefore, our presentation is about comparing different security frameworks proposed by various researchers for solving these MEC security challenges.
Next, my name is Muhammad Aziz. So I will present several proposed security frameworks that are designed to strengthen MEC system. So most proposals use multi-layered security because a single security layer is not strong enough to protect MEC adequately. However, more layers can increase latency. So researchers focus on creating smarter adaptive framework. The key categories include dynamic security and zero trust security, network and resource optimization, blockchain-based security, learning-based optimization, and edge-based intrusion detection and threat mitigation. Next. Next is dynamic security and zero trust security. This category is the most common. Dynamic security means the system can adjust itself security level automatically based on the network situation. For example, if the network is busy, the system switches to a faster encryption mode to reduce delay. And zero trust means that no user or device is trusted by default, even if they were trusted before, and every single action requires authentication. So there are four frameworks under this category, but I will present only the popular one. Next. So one of the framework under this category is the dynamic security framework for MEC migration. The problem it solves is the trade-off between security and performance. Multi-layer security gives stronger protection, but also increases latency. So the proposed solution is a security framework that keeps strong protection while minimizing delay, and it allows autonomous security decisions without human input. Next is security profile switching helps the system change security levels depending on bandwidth and network load. And there is also a latency cost model which decides whether to use strong encryption or faster encryption, ensuring both safety and speed. Next is base station authentication is included to prevent fake servers, verify data integrity, and ensure compatibility. The migration process uses a unique master key to protect the whole migration. Next is G2G service migration. The framework supports secure service migration between 5G GNOT base station through the G2G channel. Before migration, the service is put into hibernation and the data is compressed, and session handling assures that everything resumes smoothly after migration. This makes the system more reliable and responsive. Next is ZTS based MEC architecture. It has three layers. The UE layer uses connect and register identities, and at the edge layer, switches act as MEC nodes, and ZTS verifies users' credentials, and at the cloud layer, the server handles authentication and processes user traffic. I will pass next presenter.
So, hello, can you hear me?
Yes, brother, we can.
So for next, I will talk about the network security and resource optimization. Before that, my name is Ahmad Fahim. First one is combine SDN and MEC for smarter resource management, which SDN control how data move in the network, and MEC to process data closer to user. Together, the network and faster and more efficient. So the second point is focus on domestic energy and efficiency. Because this to use resource efficiency by reducing the energy consumption while keeping network data. The one is efficient and computer resource which and energy. Things
Okay, brother, we cannot hear you well now.
The system of yes, it is
Brother, we cannot hear you. If anyone in the team want to do this part? Maybe your connection is better than the brother.
Yeah, I'll do it.
Okay.
So, the first example of proposed framework is SDN plus MEC with optimization algorithm. It combines SDN with MEC for smarter resource management. SDN will control how data moves in the network and MEC to process data closer to users. Together, the network will be faster and more efficient. Focuses on balancing energy use and latency. The main goal is to use resources wisely by reducing energy consumption while keeping work delays very low. It uses an improved NSGA2 algorithm for task allocation, which helps decide how to divide the communication and computing resources for each task. Therefore, finds the best possible balance between performance and energy efficiency. It applies load balancing switch migration strategy, where when some switches, that is, the network devices, are overloaded, the system moves tasks to other switches. This prevents bottlenecks and keeps the network running smoothly. It also optimizes switch migration using an improved end colony algorithm. It helps select the most efficient path for switch migration, which reduces network congestion and speeds up the network's response time. So for the next category is learning-based optimization. The first one is DRL-based, the MEC framework. It uses deep reinforcement learning, DRL, for smart decision making. The agents of DRL will learn to make optimal computation of learning decisions based on the current network state, available resources, and security needs. It also includes dynamic offloading of tasks, where the system decides in real time whether a task should be processed locally on the device or offloaded to edge servers, balancing speed and efficiency. It also learns from experience where the agents interact with their environment, observe outcomes, and improve their offloading strategy over time for better performance. It incorporates security measures where sensitive data is protected using encryption and authorized access control, ensuring safe transmission and processing during offloading. It also optimizes performance and security simultaneously by combining DRL decision-making plus security mechanism. The framework achieves low latency, efficient resource use, and secure computation in the MEC network. And next example is secure offloading strategy. So-called hybrid encryption. It bolsters security while preserving offloading efficiency. The goal of the proposed framework is to achieve multi-objective optimization, simultaneously optimizing both latency mitigation and security metrics. The security feature of the framework is it employs the SHA-20 encryption protocol as primary security mechanism, and the framework achieves efficiency maximization by simultaneously leveraging both edge and user device resources to find the appropriate offload ratio.
Okay, next, we move on to the last category, which is edge-based intrusion detection and threat mitigation. This category main function is to detect and prevent cyber attack targeting MEC and IoT system in real time. The key difference from traditional security is that detection runs directly at the edge. This means we get a much faster response and can significantly reduce the impact of an attack. The primary purpose framework we have reviewed in this area is SEC IDS. It combines known attack patterns and unusual behavior detection at edge server. So to achieve that high level of security, the SEC IDS framework is built on 4 key components. First, the Certificate Management System, or CMS. It handles the issuing, distributing, and managing of digital certificates, ensuring that communication between edge devices is authenticated and trusted. Second, the Intrusion Detection Module. It monitors network traffic and communication pattern to detect abnormal or malicious behavior. Third, Behavioral Analytics. It utilizes machine learning to constantly improve detection accuracy, allowing the system to identify both known attacks and brand new. And finally, the real-time response mechanism. It takes immediate action when threats are detected. So, it blocking such as isolating risky device, blocking malicious traffic, or alerting administrator right away.
So our review show that all proposed framework show improved security and performance. For example, ZTS showing a 26% increase in authentication success rate, and for LTS achieving 50% lower computation time.
To recap each of our key frameworks, we look at the dynamic and zero trust security is focused on authentication, migration, and access control mechanisms, while network and resource optimization optimize the latency, mobility, and bandwidth using the SDN and meta heuristics. Blockchain and AI integration combine decentralized trust with AI-based analysis. Learning-based optimization employ the DRL, DQN, TD3, and other AI models for offloading and scheduling. Finally, the edge-based intrusion detection and threat mitigation key frameworks. It focus on the edge-based IDS, combining the signature and anomaly detections. So to conclude, MEC delivers ultra low latency and real-time performance, but its distributed nature introduces complex security risks that cannot be solved with traditional mechanisms. The modern MEC security is shifting toward AI-driven, decentralized, and adaptive frameworks using the technologies such as SDN, blockchain, DRL, and zero trust security. These integrated multi-layer approaches significantly improve the authentication, intrusion detection, resource allocation, and threat mitigation across dynamic 5G or 6G environments. While but while the approach is significant, it also have its own limitations. So the current limitation is it is not yet settled, it is not yet tested in real world and large scale environments. And it also needs the need for continuous model adaptation. Because of this, the future direction researcher or developer could focus on is by integrating the hybrid learning models, collaborative MEC frameworks, and further refining the AI models to create highly adaptive resource management systems to optimize the trade-off between security, performance, and energy in complex edge environments. Okay, so that's all from us.
Okay, thank you very much, brothers. Interesting topic. Actually, this one, if anyone interested in doing FYP, it will be a research project usually. We don't do it as practical project. We don't expect you to implement it. It's a little bit research stage now. And for master PhD, this is a very hot topic also for them to do these kind of topics. Okay, we can stop here. Thank you very much for everyone for being patient. We see you inshallah next class. We try to finish the interVLANs next Thursday, and then you can enjoy your holiday. After that, you have the vacation week next week, inshallah. Next class, inshallah, I'll give you project 2. So at least you will have an idea what will be done after the break, what you have to work on. Thank you very much, and assalamu alaikum.
Salam.
So, thank you, madam.
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 Thank you.